Hello everyone. Today we are going to study the synthesis of chloramphenicol, which is an important antibiotic used in the medicinal chemistry. So let's begin. Chloramphenicol is obtained from the species called as Streptomyces venezuelae, which is used in the treatment of cholera, in the treatment of typhoid and other infections. Before the synthesis, we should know the interconversion groups which are important in the synthesis. So the chloramphenicol structure having primary alcohol and the secondary alcohols. We should know that secondary alcohols on the oxidation gives ketone group, and in the same way on the reduction it gives secondary alcohols, and primary alcohols on the oxidations gives aldehyde. In the same way, simultaneously on the reduction it gives the primary alcohol. It is a redox reaction process. So let's begin with the synthesis. The structure of chloramphenicol, we have divided it into 5 different sections. We can also begin the synthesis with the nitration of benzene. Here we are preferring different step according to the interconversion groups. First, we are drawing the benzene ring here. And I have mentioned the interconversion group. Secondary alcohol on the oxidation gives ketone. As the carbon is having positive charge, we need to add negative charge to that. So we are adding bromide here. Then we are taking the second section. So it is a primary alcohol. So on the oxidation, it gives the aldehydes as I mentioned earlier. So here carbon is a positive atom. We are adding negative atom as chlorine. On the liberation of hydrogen bromide, it gives a product. So the product is NO2, C double bond O, Cl. Okay. Next, the different section is ammonia. And we are having in the third section as NH. What is the valence electrons of nitrogen? It is 3. So already we have hydrogen. 2 more hydrogen we have to add. As you know, nitrogen is an electronegative atom, so we are adding hydrogen here. You can't add electronegative atom to the electronegative atom. You can't add chloride here. So we are adding hydrogen, which is a positive ion. In the chemistry, you should always know about the valence electrons here. On the liberation of hydrogen chloride or hydrochloric acid, it gives benzene ring attached NO2, a ketone group, same. Okay. And now on the fourth section we have carbonyl group, C double bond O, and we know that carbon is having 4 valence electrons. So the carbonyl group we are attaching 2 Cl groups, so the valency will be filled. This group is called as the phosgene group, and it is very important for the chloramphenicol synthesis. On the liberation of hydrogen chloride, it gives a benzene ring attached to a NO2, C double bond O, CHO, H, NH, carbonyl chloride. So the next step is we are adding CHCl2. As I have said, the carbon is having 4 valence electrons, so we should fill the electrons first. So valency is here 1. So on the liberation of hydrogen chloride, it gives a benzene ring attached to a NO2, C double bond O, CCHO, H, NH, C double bond O, Cl. Okay. I have written as CH2Cl, but you should always check the valency in the medicinal chemistry or any chemistry. Valency is important. So next comes the very important step, we have to do the selective reduction and oxidation, okay, which is a very important step in the chloramphenicol synthesis. So this gives the final product chloramphenicol. I will show you how it is. Okay, this is the final product, chloramphenicol. First, I am going to write the benzene ring, NO2. As I mentioned earlier, secondary alcohol on oxidation gives ketones, as well as primary alcohols on the oxidation gives aldehydes. The same procedure is applied here. Here they undergoes reduction process and it gives secondary alcohol and primary alcohol over here. You can write only selective reduction here, no need of oxidation. Okay, this is the final product. Thank you.